Hello everybody and welcome to another video of data analytics. Today we are going to be looking at the if statement in Python. So the if statement in Python is a big deal, okay? Well, the if statement in general is a big deal. So far, if you've been watching the previous lectures, you have been making assignments, you're making programs that have a beginning and an end and a predefined sequence of statements that always take you to the same ending, right? Step 1, step 2, step 3, step 4, 5, done. Like you're making a cake, you got your instructions, and you do not deviate from those instructions, okay? You just go step by step. And this is very cool, you know, especially if you have a lot of steps, because one of the big powers of programming is that when you are making a program, you only do it once, but when it's done, you can run it as many times as you want and avoid the steps. So even this is enough to really give you some power. Like, you know, if you have a program that's going to take 100 pages of numbers and add them together, and you feed it all those pages and it adds them together, and it always gets you the same result, you know, based on the addition of the numbers, which could be different, but it still takes the numbers. It's still saving you a lot of work because you would otherwise have to add them, right? And so, you know, your programs do have some flexibility right now in the input category. Because I mean, if the numbers are always the same, if every time you run the program you have this exact same input, like you hard-coded the input, then I would argue that why have a program at all? Just have literally a print statement of your program that outputs the correct answer each time, and then you're good to go every time, right? But you've gone further than that. You created a program in the assignment where you took some number and you computed something based on that number, right? And so you have different values each time, and so your answer is different. However, the predefined sequence of what you're going to do with that information has been the same. So you add the numbers together, you multiply them together, you divide them, but you always do those operations regardless. It's great, but you're missing out on the biggest and most powerful thing that you can have with a program. And that is, of course, choice. Freedom to choose, I suppose. You have your freedom of choice. The if statement is going to give you that power. So what the if statement, also known as a conditional statement, allows you to do is it allows you to tell the computer to make a decision. Now, hopefully, but you don't have to, but you probably really should, most 99% of the cases, you should tell the computer to make an educated guess based on some factors, right? So, right now, your programs are like this. You have a beginning, and you have an end. These boxes represent things that you do. However, what I'm going to show you today is a program that has a beginning and an end, but it also has choice. And that choice, kind of like a intersection on the road, allows your program to make a decision based on some data and based on what you tell it on which path it wants to take. Which at the end, it could lead it to the same ending. It could lead it to different endings. But the point is that it's no longer something linear. But just, you know, it can diverge. Now, you might be asking, why would you want to do this? Well, that's the beauty of it. You get to choose why you want to do this. So, for example, suppose that you wanted to make a program that could do a lot of things, you know, but deciding what to do is based on what kind of data you're feeding it. So, you know, for example, you have a program like WebEx. You know, WebEx allows you to make phone calls, but also to receive phone calls and whatnot. There's a path. It's like when you start the program, you ask it, what would you like to do? Do you want to make a phone call? Do you want to join a current meeting? You want to start a new meeting? Do you want to create a meeting like for the future? What do you want to do? Right? Or an email system. You open an email system, you know, what do you want to do? You want to check your email? Do you want to send an email? Do you want to create a draft? Do you want to edit a draft? Delete an email? archive an email. Now, for the data analytics perspective, what are some of the choices that you could do? Okay, well, something very, very basic as to why you would want to have choices. Let's say you're dividing a couple of numbers. And, you could be dividing 5 divided by 2, 10 divided by 2. You could be doing your integer division or your float division, whatever you want to do. Suppose you hit a situation where you're dividing by 0. You don't want to do that, right? Bad things happen when you divide by 0. You get a floating point exception. So what could you do? Well, you could use choice and say, if the number I'm trying to divide to happens to be a 0, then either not do the division, take a different path that doesn't involve the division. So like, for example, here's my number that I'm feeding it. So here's some numbers. And then I'm going to check if those numbers, if the number here happens to be a 0, then do not divide it. Instead, do something else, such as exit the program and say, hey, you're trying to divide by 0, something went wrong, or don't divide by 0. Like, for example, suppose you're trying to take the average of something and that there's 0 items that you're taking the average of, then you can just say, can't take the average, or the average is going to represent nothing, or 0. You might just say, well, the average is 0 because there's nothing. Whatever it is that you choose to do that, it's up to you. Or you could just take the normal path, which is to actually divide the numbers by the total number of items and then keep going. And so your programs are going to become like little trees. And they're going to have completely different endings. And every time that you have an if statement, you could potentially have sort of like a parallel, parallel universe or something, like completely different path. And by the way, this is cool and all, but as you can notice, there's only kind of like a 2 paths that you take, right? It's just a Y. But that's just the case. You could actually have something like this. And then these go on their own. They could split again. This could split like 40 times. And so on. That's okay too. Your decisions do not have to be binary. They can be to any degree that you want. You could have a million different cases. Obviously, I wouldn't want to code a million different cases if I were you, but you can do it if you want. That's the power of conditionals, and that's the power of the if statement. It's going to allow you to do a lot more in your code. Your code is truly going to react. It's going to be interactive, and it's going to be able to handle different situations. So in your head, whenever you're thinking, how am I going to code this? How am I going to apply this to data? Think about decisions that you want to do. You may want to do something to some kind of data, but not to some other kind of data. And whenever you have something like that, where you're like, well, if what I'm getting is this or what I'm getting is that, those decisions, they're going to be your if statements. Okay? At first, an if statement for someone that has never programmed can be a little bit tricky to understand, but trust me, as the more you do it, the more you get it until it becomes second nature. You just kind of have to translate the real world into if statements, and then you're good to go. So it just takes some time, okay? So we're going to go with baby steps. What I'm going to start out showing you is how to write an if statement. We're going to do a couple of those. We're going to kind of expand ourselves into how to make these sort of multi-branch situations where you have more than just a binary case by doing something what is known as the else if. And then from there, maybe we'll see. We'll see where we get, because I think that'll be enough for the day. Okay? So, in Python, and by the way, a lot of programming languages, in fact, I would say pretty much all programming languages, although that's a big statement to make, are going to have some kind of conditional. So, there's probably some weird exception out there, okay? And most of them are going to be using the word if for that, okay? One way or another, it might be slightly different, but it's kind of the same thing. So, Python is no different in that it uses the if. What changes is the syntax or the grammar or the formatting of how you use it, okay? Python's actually really relaxed about that. Some languages force you to say something like if, and then you put something in parentheses, and then you have these curly braces to identify things, etc., etc. Python goes kind of like the nice and easy way and just says, nah, just write the word if, write whatever your conditional statement is, and then when you're done with that, put a colon, and then in the next line of code, write whatever you want to execute if that statement evaluates to true. So if the if statement, statement evaluates to true, execute this code. So if we're looking at a little tree, when we hit that if statement here, we have the branch if true. We also have the branch kind of like if false. What you execute there is if you run it if it's true. If it's false, you just skip that and you keep going to whatever's after the if statement. This is the most basic example, okay? So the green code is what's going to run only if the conditional that you're evaluating evaluates to true. What's the conditional? Whatever's right here. On the other hand, you have the stuff down here. This code is going to run always, regardless if the if statement evaluates to true or false, because it's not part of the if statement. We consider the if statement to be basically everything, from here all the way to here. You'll notice something about this. I have some space here, okay? This space is not accidental. Now this is something Python specific. Whenever you're writing an if statement in Python, and I mentioned this at some point in the videos about scoping rules and spacing and tabulating and whatnot, but now we're really going to see this. Whenever you have an if statement in Python, it needs to know which of the code beneath it is part of what you're supposed to evaluate when it's true versus stuff that just runs regardless. So like, for example, if I have 3 lines of code, I'm going to call them lines 1, 2, and 3, and line 1 happens to be the if statement, like the if part, and this is what evaluates when true, and this is just code after that, which runs regardless, then I would say that this is 3, this is 2, and then this is 1. If the code is just like this, 1, 2, 3, how do I not know that these two are actually supposed to both be part of the if statement? Like, how do I know the difference between them? Again, some programming languages will use curly braces. So they'll put in curly braces the content, which means whatever is here and whatever is here, that is supposed to be inside. That's the stuff that evaluates when true. Some languages use the curly braces because of that. Python, you don't need curly braces, but you need another way of doing it. And so Python said, okay, we're just going to physically move this like this so it visually looks different. Like, okay, this has to be part of that. And this is flush with this, which means that it's not part of it. So that's just Python's decision to do that. Whether you like it or not, it's up to you. I think it's okay. I mean, a lot of other languages like C++, when you're using the curly brackets, you still tabulate things. So you still will tab things and put things here like this. Code will go here. Because it looks much easier to read. It's nicer than putting it like this. This is a little bit harder to read when you're scrolling through code. And then the code here like that. So Python just kind of realized that programmers do this anyways, and it's like, well, if programmer's going to do it anyways, then we don't need these things in here. It's less writing to do. Place that with a colon, and not even require the parentheses. And that's how Python came up with these things. Well, at least that's how I think they came up with it. They might have just like flipped the coin and said, well, it's better, let's just go it this way. Okay? Python's all about writing less to do more. And so really, I think that approach matches why they did it this way. And, you know, there are some disadvantages to doing this, such as, well, you have less space. If you're trying to make your code be nice and tight, where it's like, it's not overflowing and you have to scroll left and right to the screen and it's just kind of nice and rectangular, like vertical, this is space that you're technically wasting. You can't use that space anymore because you have to tab things. So that's the disadvantage. Another thing is you have to be careful, of course. If you forget to tab things, then of course it's no longer part of the if statement. And finally, if you have multiple lines inside of your if statement, you got to make sure that those actually line up, that this is actually flush like this. You can't end up with something like this. So suppose that you had a situation where we have 1, 2, 3, 4, and 5. 1 is that if part, and then let's say that this 2, 3, and 4 are all part of the inside of the statement, so what runs when the condition evaluates it true, and then 5 is just the rest of the code that's not part of the if statement, okay? You have to tab these things, so you have to move them. But if inside of this, you decide like, oh, I'm going to do this like that or something, then this will get confused. It's like, oh, whoa, what is this? Like a something inside something else or what? Like this is not flush. It'll yell at you for that. It'll also yell at you if it's like this. It wants everything to be flush, okay? It wants this to be flush right here, and it wants this to be flush right here. Otherwise, you're gonna get yelled at by the interpreter. And I will show you what that yelling looks like so that you don't get to see it and I see it, okay? I don't want you to get yelled at, but that's fine if I get yelled at. All right, so that's it. At least that's the syntax of it. Again, at this point, you're still not quite sure how to do this, but let's go back in time to last videos when we talked about conditionals. It's been a while, actually. We talked about the comparison operators, and then we talked about arithmetic operators, but we also talked about these conditionals, comparison-based operators and whatnot. Logic, okay? So this logic right here, we had the and, the or, and the not. And we had things that would, we had a false statement and a true statement, and we said if we have a false statement and a true statement, false and true, things evaluate to false. But if we have false or true, then things evaluate to true because the or takes at least one of the two, which happens to be true. So then it just the whole statement is true, right? Also, we had the not, which just flips the logic. And so it turns out that these things are useful when we're doing an if statement, because an if statement can be as simple as asking one question, but it can also be a combination of a million different questions. And what kind of things you're going to have there, again, depends on what you're working on. So let's say that you have a file, but depending on the file extension, you want to open it with a specific library. So let's say you have a .txt versus like a .csv versus like .xls, right? Excel, comma separated file, and txt. So the formatting is going to be different in these, but also like the file in general, like how it's structured will be different. Like, the txt is probably going to have its own system, but maybe not, maybe not, right? And so the point is that you have these three different files that you want to open up with the three different things. So you might do a check to see what the file extension is, and then save that to a Boolean variable, which then you can check in the if statement. Furthermore, even within the same file formatting, you might have something that is in the text file that even though it says .txt, it's using the same formatting as a CSV file. In which case, you can still open it with a CSV thing, even though it's .txt, but you have to check it first, right? So the point is that you might have to do multiple checks, and depending on all of those checks, you have to make a decision. So your if statement might be more than just one question. It might be multiple questions put together. The way you put them together is, again, with these logical and, or, and not. So you might say like, okay, if a file is a txt file or a CSV file, then go ahead and open it with a CSV. That would make the assumption that even though it's a text file, it is formatted as a CSV file. However, you might have a thing where you want to combine and say, well, if it's a txt file and it's using the CSV format, or the file is a CSV file, then go ahead and open it using the CSV system. So let's write that down. So suppose we have if a file has file ending txt or CSV, we can open it using CSV. If and only if the txt file is formatted that way, or it's .csv, right? So this is how we normally would write in English. We say something like this. However, this doesn't really translate into a clean if statement. So we're going to have to kind of finesse this around. Because we say, first of all, it's really wordy. So it says if a file has an ending txt or CSV, we can open it using CSV if and only if the text file is formatted as a CSV or it's a .csv file. Okay? So first of all, we can say, okay, let's take the first part, whether we can open with text or CSV. So, if we have our if statement, and the true part here that evaluates the true is like open with CSV library. Okay, but we only want to go in there if whatever's in here evaluates to true. Okay, so true is open with CSV library, and then otherwise we don't do anything. Okay, so what do we put for the question mark then? Well, we can say if CSV extension or .txt extension, if we leave it just like this and then we have our open with the CSV file, then this would open all CSV files and open all TXT files. However, we don't want to open TXT files that are not following the CSV format. So I'm not talking about how we even check that format right now. I'm just saying, how would we put the statement together? Well, we use the AND statement. We say AND .txt file is CSV formatted. Okay? This is okay because the order of precedence of the or, and not command help us out. Think about like math, right? In math, multiplication has a higher order of precedence than plus and minus. So multiplication division is higher. Of course, higher than all of them is things like parentheses, right? So when it comes to the logic or and or, the or and not, the not is the highest because it's like touching whatever is flipping around, and after that comes the and then finally comes the or. In fact, sometimes you'll see a plus used for the or operator, and you'll see like a dot, like a multiplication used for the and so that also helps you remember that the multiplication goes before addition. So in this case, the first check that's going to happen here is actually going to be the check between this statement, whether this is true, and this statement, right? It's going to check both of these, and it's going to perform an AND on them. And on the other hand, it's going to check this and perform an OR with the green square. And ultimately, the result of that will be the result of the expression, right? So the OR statement says that if something evaluates as true, we're good to go. So in this case, if the whatever this is, like purplish color, if this evaluates as true, which means that the CSV extension is being used, then we just open it with CSV, which is what we want. The other case is more complicated because for that to be true, we have an AND. So both of these steps have to be true. One of them is that it's a text file, .txt file extension, and the other one is that it is actually formatted as a file. What I mean by that is like, suppose like comma separated files means that like if you have a file, it's something like this, like blah, comma, blah, comma, blah, and that's how each line goes. And then this is like Excel, so like this will actually like make it be like this is where this goes, that goes there, that goes there, and then the next line and so on. So it's a CSV is like a really simplified Excel spreadsheet where you just like use commas to separate cells. Okay, but you could because it's just text, you can save it in any file format. So you could end up with a text file that is actually CSV, but it's just labeled as TXT because who knows. And this who knows thing, you might be thinking like, well, that's not gonna happen. No, it is gonna happen. Trust me. As I said before, like 50% of the work when you're doing data analytics doesn't even have to do with doing data analytics. It has to do with cleaning up data because data is not clean. It's usually just nasty and like messy and whatnot. And tidying it up and cleaning it is half the work. So heck, I would take it if somebody gave me a TXT file that would have things already CSV'd in it, but it's probably not even going to be that nice, okay? But anyways, the point is that it's just an example for now, but there is some reality to this example, okay? So again, this is a combination of using or and. The and is to connect both statements to require both of the pink things to be true, or the alternative, which is for the purple one to be true, which then it just kind of goes and does everything, okay? So that's a good example of using or and. Again, this Boolean logic sort of translation of going from this to this is like when in math class back in the day, they would say, okay, this is a word problem in math. And trying to take that word problem and convert it into the math equation that you know how to solve was critical thinking, right? And a lot of people struggled in school with that because it takes a certain mindset to be able to translate a word problem into a mathematical thing. This is like the same thing. Literally the same thing. Taking a word problem, or in this case, a decision, an if statement in word mode, and converting it into an if statement in programming. Although I would argue that this is a little bit easier than some of the math ones, because some of the math ones can get pretty hardcore, especially if the formulas are pretty fancy, right? I think here the idea is that programming is made easy to help you out. As long as you know this or and, I think you got most of the work done, okay? So, obviously, these three things that we have here, so this, and this would be your Boolean values, which you have to figure out how to get them, right? I haven't even talked about how to check extensions or how to check if something is formatted, etc. Again, that's irrelevant for now. Okay, so now we know how to do the basic syntax. So the spacing, the colon, and that's pretty much it. And then we know at least how to build the basic idea of an if statement. Let's just go ahead now and start doing some if statements. Rather than doing these Booleans though, I'm gonna go and switch around and use comparison-based operators because this is the easiest kind of if statement out there. You know, when your if statement is strictly just math-based, like comparing two numbers, like, you know, I'm going to write a program that asks your age. And if you're underage, it's going to say you are not allowed to vote. If you're over the age of 18, then it'll say you are allowed to vote. Those are really easy to do because the decision you're making is strictly based on a mathematical value. And at the end of the day, you know, all if statements are going to be evaluated true or false. And because computers happen to work with just numbers, at the heart of everything is probably numbers involved. So it's not that far-fetched to do comparison-based stuff. But anyways, the point is that what I'm going to do is I want to check two things and use these operators here, greater than, less than, equality or non-equality, and then make that be what gives me that logic that tells me whether something evaluates as true or false. Okay? So that's kind of what we're going to start out with. So here we have our terminal, or actually our IDE with Visual Studio, VS Code. And let us write our first ever if statement by just writing a statement that always runs. So we write if true. Notice that when I press enter on an IDE, it automatically taps it for me. You can see here it tabbed it all the way here. In fact, if I highlight that, it tells me expected indented block. That's because it expects me to indent the block after that. Because you need to have something. You can't just have two lines flush. Like line 4 here to just be flush with the IF. Like I can't just do this. Blah. Because then it's really confused. It's like, wait a second. Where's this code that I run if this evaluates to true? So it needs to have something in here. Okay? So I'm just going to go ahead and call print and say true statement. And I'm going to put down here another print that says false statement. Okay? This is the most basic if statement because this if statement is always going to run here, right? Although this is technically not quite the best way to list this because this is always going to run, even though this is true. So really this shouldn't say the word false. This should really just say statement. Because if it's true, it's going to run true, but then it's also going to run this. As I said, this always runs after because it's flush. Okay? So if I run this, you can see here that I get if statement because I have this if statement print statement here. Then they get the word true statement, and then they get the word statement. Let's get rid of the if statement thing up here for now, okay? Or here, let's just comment it down. I want to leave it as a label for this file. So as you can see, it's always going there. Although this is not the most exciting of if statements because, as I said, it's always evaluating to true because we literally put the word true there. But again, it's a good example just to see how this works. And I encourage you to try this yourself. Let's try false. This time, all we get is the word statement printed, as you can see here. That's because this if statement evaluated to false, which skips this line and then just runs this line. As I said, that will always print out because it's not part of the if statement. The if statement is just this. Let's add another line to the if statement. Let's call this more truth. If I run this, it's still not going to print out because the statement is evaluating to false. But if I change this back to true, then I get true statement, more truth, and I still get the statement, okay? All right, cool. But, you know, let's do more than that. It's just not very exciting, is it? So let us try to do an actual comparison, okay? So let's just start by hard coding some numbers. So let's say 5 greater than 4, okay? So if I say if 5 is greater than 4, run this. What this is saying is if this statement evaluates to true, it's going to run this. Otherwise, it's going to skip it. Of course, 5 is greater than 4, so we see true statement and more true being printed. But if I switch this to a 3, then it's not going to print, right? So I hope that this is trivial enough that you're starting to see how it works. I can, of course, use something like greater than or equal to, and then if I put a 4, then that is actually going to evaluate to true, right? So let's try equality. So let's say not equals like that. If 4 is not equal to 4, run that. As you can see, I only get statement because they are equal. So it's like, no, they're actually equal. So like, this is false. Of course, if I switch it to equality, then they get it true. So, yep, that's pretty much how it works. Again, coding an if statement is not hard. Coding an if statement is a piece of cake. What is hard is trying to come up with the logic to put up here. That's what's hard. That's what you strive to do. You know, with time and practice, it will be easier to translate that what you're trying to do with what the code is actually doing. So, but the syntax is there for all of you to see. Again, you just put that condition in there. Now, let's try some variables in there. So let's go ahead and write var1, var2, and let's just compare these two. Okay, so var2, var1, maybe let's do less than or equal to. Okay, so let's just say var1 is going to get a 3, var2 is get a 2. So you can do with variables too. In this case, 2 is not less than or equal to 3, but if I make them equal, then I am going to get truth, okay? You can also, let's try using the and and or. So let's put an and in here. If var1 and var2. Now, if I run it like this, it's probably going to go and say this is true, because it turns out that while you're looking for Boolean variables or Boolean values, when you're looking at an if statement, if you feed it something other than a Boolean that's not a 0, it'll just assume that to be true. So in this case, it's saying 3 and 3, and because 3 is a non-zero value, it sort of interprets it as true. And this may not be something that you intend to do, so you have to be careful about that. I'll repeat it one more time. When you're trying to compare two things with an and or, it should be used to compare two Boolean values or two things that are either true or false. If you feed it another data type, it will assume that data type to be true unless it's a 0, in which case it might actually assume it to be false, I believe. Let's try it, because Python might be a little bit different than C++, which is what I'm thinking. But no, it is the same. So as you can see, even though these are numbers, whole numbers, anything that you feed in here, doesn't matter what it is, so like a float, actually no, that doesn't exist in Python. If you do that, it's still true, okay? If I do 0.001, it should still go through because it's not 0. It's only when you do 0, 0, which by the way, will it work like that or will it yell at me? Oh, it didn't yell at me. 0.00, that it actually validates false because that's a 0, okay? So, but you don't want to do that. You probably don't want to do this. Like, you shouldn't be doing this because what does it mean? Like, what does 1.5 and 2.8 mean? That's just like, huh? What you want to do is you want to use this with Boolean values. So you can say something like 5 less than 3. That's a statement. Or you could also flat out say like something like false. Okay? Now this is good logic. Bar 1 is a Boolean value and bar 2 is a Boolean value. And now you're ending them together. So what is this going to equal? Well, I don't even need to know what this is equal to because this requires both of these things to be true to run this. And because one of them is false, then it'll automatically say it's false, right? If I run it, I get that that's the case because I don't get that statement executed. However, this is also false because 5 is not less than 3. So even if I did switch this to true, it still say false and yell at me. Yep, but if I switch this around, then now I get this, right? So, very good. If I, however, flip this back to how I had it, and I have it now not working, if I switch this and to an or, then it goes back to being true, okay? So that is how you use the and the or. So let's kind of make a equivalent to what we were trying to do earlier with the text file stuff. So let's see if I can put that on the side here. Hold on. There we go. Okay. So that's the if statement. As you can see, this is our tabulation, by the way, that we're doing. And oh yeah, let me tell you how it'll yell at me if I do this. It says indentation error, expected an indented block. And it puts an arrow to the line where it says and it says here line 5. That's good. It tells you the line number because then you can go and fix that. So this is what you would get if you ever screw that up. So it's good to know what the error looks like because it just happens to all of us at some point. And yeah, that's pretty much it. Of course, remember, if you do this, you get no error. But if you intended this not to be part of the if statement, then you gotta be careful about that. Okay, but anyways, let's go ahead and put this here. Okay, so that's what we're trying to do. So let's try to do it. So let's make 3 variables. We'll call the first one is CSV extension. We'll read this from the user. How about that? Enter if file is .csv. The next thing we're going to do is we're going to say is txt extension. Actually, we should say is file.csv. And we're going to improve this better, by the way. Yeah, this will be actually a good example. Then we're going to say is file.txt. You can see how this is redundant because if they answer yes to this, it shouldn't be able to answer this at all, right? So we'll do an if statement to avoid that. But for now, we'll do it simple. We'll improve it. And the last one will say is txt file formatted as CSV. So, we'll say is txt formatted as CSV. That's a really long variable name, but that's okay. is CSV file. Okay. So now we're going to put the same thing that we had in there in that if statement, which said if is CSV. You can use tab, by the way, to autocomplete in this, or is txt and is txt formatted as CSV. And if so, we got our true statement, which will change to say process as CSV file. Okay? Like that. We run it, and it's asking us, is the file a CSV? Yes, it is. Oops, I'm like modifying the text here. My bad, I gotta click here. Yes. So right now, we don't have it set up to accept yes or no, so we have to use numbers 1 and 0. So 1 is true, 0 is false, so we'll say 1. Is file txt? No, it's not. Is the text file formatted as CSV? Technically, yes, but I'm just gonna say no because it's not a text file. So it'll still say process as a CSV. If I run it again and I say is file a CSV, I'm going to say no. Oops. Is the file a TXT? I'm going to say yes. Is the text file formatted as CSV? I'm going to say yes. Process as CSV. Cool. Let's try saying no. Is file CSV? No. Is file TXT? Nope. Is text file formatted as CSV? Nope. Process as CSV. Huh. Okay, that should not have happened. Oh, I see what happened. Ooh, yeah. Okay. So what happened here is that this is being read as a string. So okay, this is actually, I'm really glad this happened. So what is happening is input here, as we saw the other day, returns to us a string with the user's values. It's a string, and that string is represented as ASCII characters, and the ASCII table has a number associated with each character. So if I really fast pop up the ASCII table here, we can see that even though we type 0, 0 is also a ASCII value that is 48. It's really tiny, but that says 48. And so that's the issue. This is actually storing either a 48 or the char ASCII, probably more likely the char ASCII. But again, neither of those are 0. So everything is setting it to true. All these 3 variables are being set to true regardless of what I type. I could write potato in here and it would still set it to true. So I could just write random stuff and it's still about true. What I need to do is I need to cast it, which I think I mentioned the other day briefly. But if not, for now, just bear with me. We're going to write the word bool to convert these to Boolean values and then put it in parentheses. As you can see by the autocomplete, here, I'll write that again so you can see that. It returns true when the argument x is true, false otherwise. The built-in true and false are the only 2 instances of the class bool. The class is a substance of the class int and cannot be self-classed. What that is saying is that this might make me have to turn it into an int first. Yeah, it probably will, but let's try to run it anyways. Let's see what happens. See if this is enough. Yeah, it's gonna make me turn into an int. Okay, so I gotta turn this into an int. So I gotta do this twice, basically. So I gotta first take the value, the number there, and I gotta change that into an integer, which is gonna be 0, and then I gotta change that integer into a Boolean. Although actually at that point, I might not need to turn it into a Boolean because the integer 0 will arrive to false. But I'll do it anyways to be extra safe. Finally now, if I run this with all falses, then it does not do that. Okay, perfect. All right. So that is a perfectly awesome example of how you have to be aware of how if things are not Booleans, you might be thinking as this was interpreting it as a false statement to put a 0, but it wasn't, because it's interpreted as anything that is not a 0 or false will be interpreted as a true statement. A negative number will be interpreted as a true statement. You have to be aware of that so it doesn't mess up your semantics or your logic. Okay? So this can be improved though. Sure, we could ask 3 questions, but as you can see, they're redundant. So how to make this better? Well, we can make this better by taking advantage of not just the if statement, but the if-else statement and the if-else-if statement, okay? So, and we're probably not going to get through all of that today, which is fine. We will keep going next time. I'm trying to go as slow as possible to make sure that we are on the same page, because this stuff is fundamental, and otherwise we'll struggle later on. So, right now we have the most simple form of the if statement. In fact, let me copy our little colorful picture here, along with this. Technically speaking, if we were to draw this sort of line processing of what we did, what we really end up with is something like this. This is the real sort of path of what we've done. So we have some statements here, which are whatever's above the if statement. And then when we hit the if statement, if it evaluates to true, we're going here. If it evaluates to false, we go here. However, right now, what we're really doing is we have some stuff here we do if it evaluates to true. But from there, we also go here, right? That's really what this looks like right now. This is sort of like extra stuff that we do, because at the end of the day, we do end up going back to this, okay? So based on the colors, that would actually be this little blue-purple color. And then the green is going to be what's inside. And the if statement condition is the pink one. So that would be this. Okay? And here, so that we don't make it too big, let's just get rid of that. But you get what I'm saying. There's stuff, there can be stuff above it and stuff beneath it. It's not the point, okay? So really, that's the visual representation of this. Okay? Right there. We have some extra stuff we do. We're not really doing any other stuff if it's false. What I want to do is say, okay, this is cool and all, but what if I want to run other special code if something evaluates to false? That is only run if thing evaluates to false. Well, one of the things that you can do is you have to make a decision and say, okay, cool. I want to run things when the statement evaluates to false, but do I also want to run something special when it evaluates to true? If all you're trying to do is run special code when it evaluates to false, then you can just leave the same thing that you have here and just kind of flip this to a false. And by using some not statement. So say if not, and then put the same thing. Okay? That's one thing that you can do. That's a very simple thing to do. So if I want to do that in the code that I had, all I really have to do is put a not at the beginning and then put parentheses around all of this, and that just flip the logic of that. That's some just Boolean algebra, basically. Okay? That's okay. That's not as interesting. What I'm trying to say, though, is what if you want to run code both on the true situation and on the false situation? So what you really want is something like this. So if true, go there, but if false, go here. Run some other code, completely different color now. So let's do that one. And that code only runs if it's false, and then eventually you go back to whatever's after. Okay? So really you end up with something like that. So you have code that runs when true, you have code that runs when false. Either way, after you do both of those, you end up doing whatever code's beneath it. To achieve this in programming, you need more than the if. You need the else. So like, don't move, or else. Now we're learning the or else. Okay? So the else clause of the if statement allows you to execute code when the if statement evaluates to false. Okay? So let us update what the diagram here would look like. Okay? So for now, let's move this as far to the side as we can so that we can put this up here. And now let us copy this, paste it here, like that, and then put this one to the side as well. It's really big. I should have made it a little smaller. Let's shrink that. Okay. There we go. Let's bring it down a little bit. Okay. So we want to modify it to achieve that. So what we're going to be doing now is we are going to adding the else clause. So first of all, let's take this purple stuff and move this down a little bit. And now let's go ahead and erase this, since this else, the else part of a statement that you're about to see has always has to be part of an if statement. You can't just write a random else. There can be no else without if. You can have if solos like we've been doing, but else's have to be part of an if statement. You can't just throw them in randomly, okay? And the way you do that is you write the word else. Like that. You don't need any Boolean condition for that. There's no pink in there because, again, that's going to run whenever this evaluates to false. So if it goes to true, runs that. If it goes to false, then it's going to run this here. Oh, I didn't realize that I was already using that color. Oh, snap. Let's use another color then. Let's use gray. Okay? So this is our gray. Okay? So this will run if the if statement evaluates to false. Execute this code. Okay? And just like the if, the code should be tabulated in Python to avoid problems. Now, as a good practice, I would tabulate it with the same width, so like 1 tab key or 5 spaces or 3 spaces, whatever you choose, but you make it flush. So make these flush like this. Okay? Make them flush. In theory, you could do this with its own thickness, so like this or like that, but that's just nasty and like no, just don't do that. Like there's no reason to do that. Okay? Keep everything standardized. It makes the code easier to read and easier to edit, and like yeah, there's a big, I could go on a long spiel about why you should make your code readable and beautiful and good, but let's just, there's no reason. This is like malicious if you intentionally tab it in a different length, like different width than the if part. Okay? So yeah, that's pretty much that. So as long as you do that, then you are pretty much good to go. And so now let us just close that here, and that is pretty much what that looks like. Okay? So when would you want to do this? Again, this is more choice, right? So now you have the ability to run code that runs when something is true, and also some code to run when something is false. So let us change our code a little bit in this thing here, okay? So now, we have our if statement that says process the CSV. The else statement is going to be maybe to process, or to say do not process as CSV, process as whatever, or something else, like whatever you had in here. So that's good to have. Another thing you can do is you could actually bring these questions in and put them inside on the if statement, right? So for example, this text file question should only really be asked if the first question is answered with a no. So we could totally put that question in, we could initialize this variable to false, so assume this is false. But then what we can do is we can only ask the second question about whether it's a text file only if they answer false to the first question. So we could say if is CSV not equal to true by saying if not CSV, if not is CSV, then go ahead and ask this question. Otherwise, go ahead and ask it. You know? Actually, well, I guess you don't really need the else statement here. Yeah, you don't quite really need it. You could have just stuck with the if statement. But okay, that's fine. Because you could just say something like that. Same with this one, actually. You want to ask this one like that. Notice that I'm initializing the variables to false because they need to have some value associated with it. Oh, here. Actually, that's a good point. Maybe I want to set this based... No, actually, no, I don't want to confuse you with something. No, let's just leave this example be as is, actually. This example has kind of expired what we want to do, okay? So, yeah, we'll leave it be like that. So if we run it right now, you know, if it asks if it's CSV, we say 1, then it processes CSV, right? No more questions asked. Otherwise, if we say it's not a CSV, now it asks us if the file a text file. If we say no, it still asks if it's a CSV, right? So we would want to have this only be asked based on the answer to this. So we can do that by putting this in this other parallel if statement, or eventually what we will learn about next time, which will be nested if statements. But for now, we can totally do that on its own thing, just to make it kind of cooler. So if not is txt file, like that. Okay. So if we run this now, if the file CSV would say yes by putting a 1, then yeah, that's a good point. We have to do some logic here. Yeah. So now it's still asking us this question. So we say if it's not a txt file, or actually no, if it is, we want this to be running, right? Yeah, that's why. Okay. So if is the file a CSV file, if it is, by putting a 1 here, there we go, then it processes. If we say no, then it asks if it's a text file. If we say yes to that, it asks us if it's formatted. So we can answer whatever. Let's say no, then it doesn't do anything. It uses the else clause. We can also say it's not this, it's not a text file, so do not process. So you can see that. So now it's only asking us the relevant question. So there's the power of your if statement. The else here is kind of being not used that fancily, but we can change that in a minute. Let's just do another example. Let's use a cool example where we're doing an if-else. So, for example, let us say that we have the average situation, okay? So we're going to read in some numbers from the user. Well, no, because then that would require us to teach you what lists are. So let's just write in some variables in here. Okay, so let's just say we have a number, which is the sum. So let's just say that we read from the user. Okay, let's say we're creating a division calculator for the user, okay? So we're gonna take two numbers, the numerator and the denominator, basically, okay? So we're gonna call this num gets, so first of all, let's do an introduction. So welcome to our division calculator. And then it's gonna say input, please enter the numerator. And then we're gonna say input, please enter the denominator, right? That's the divider, basically, okay? And so, first of all, what we learned from the last one is that this is gonna be read as a string, so we wanna make sure we convert that to an actual integer. Now this could be a float too, but we'll just stick with integer for now, okay? So, naively, without if statements, you could say something like, well, okay, say print the answer to the division is, and then put ans here. Let's just say ans is equal to num divided by them. And then I run this. Please enter the numerator, let's say 1. Please enter the denominator, let's say 2. The answer is 0.5. Okay, that all worked out. Although I would like to put a colon and a space to make it look pretty. Okay, so this all works fine. We could try it again. We can say 8 divided by 2. And it's all good, right? But guess what? Let's try to do 10 divided by 0. Bam, exception has occurred. Blah, program died. Okay, not good, right? So let's use the if statement to save us from here. So we can say like, we could say, if the denominator is not equal to 0, go ahead and do your division like normal. Okay? And then print it out. Otherwise, if it is equal to 0, go ahead and print a message like division by 0. Try again later or something. Try again. And don't forget your colon. You do this. This time, let's try it. Let's try put 10, 0, division by 0. Try again. So, if you try to do this without the else clause, I mean, you could have done something that says like, if then is equal to 0. Or actually, technically, you could be fancy and say if not then. Because that would be the same thing as saying then equal to 0. But I would say that's not very readable. So I would put then equal to 0. Then you can see the division by 0 part, right? But you need the else clause to, because otherwise, like we needed, you would then you would still put the division, and the crash would still happen. So I don't see an easy way of avoiding the issue here. I mean, you could also put, you put an if statement that says like if then is not equal to 0, do the division, and then put another if statement that checks if it's equal to 0, but you're still gonna have this print statement. Okay, so there's no clean way without using an if statement to stop the division and then give out an error message. You have to sacrifice something, but not with the if statement, because with the if statement you can have two choices, and then that way you only print this out if you got an answer, otherwise you print this out. So this is a good example of the else clause because there's no other way around it. So you're stuck with it. Okay, so if and else are so popular, like you will probably use them both, but if you just if part, it's okay. It really depends on what you're coding, but ultimately you want to have that split. Okay, we still got a little bit of time, so I am going to try to throw in one more scenario, make it even more complicated. But remember, here making things complicated is not to make your life harder. It's actually to make it easier, because you want to have the ability to make all these different sort of paths, so that you can do the code, make the code do what you want with the least amount of writing and the least amount of work. Okay, so I'm going to take this and I want to modify it. Okay, now I want to make 3 branches. So I like having my false branch. That's cool. That's my if something goes wrong, do this kind of branch. So I'll leave that there. And I also like having my true branch. If my original if statement evaluates are true, I like having that. So I want to leave that in there as well. However, I would like to have a 3rd branch, or more, but let's just do 3 for now. I like to have another branch that has another check in it. So in this case, I want to have an elif branch, also known in some languages as else if. This else if branch is going to check another condition, a brand new condition, before going to the false branch. So it's kind of like, imagine somebody comes to you and says like a kid comes to you and says like, can I have a piece of chocolate? You know, and you're like, no. And they're like, but can I have ice cream now? You're like, no. And they keep asking questions afterward. It's like they ask you 5 questions before they finally give up, kind of thing. That's kind of what you're doing here. You check a condition. If it evaluates to true, you're good to go. You run your code. If it evaluates to false, before you automatically go to the false branch, you check other conditions first. And you say, well, what about this? Well, what about that? Well, what about this? What about that? And finally, as many as you want, but don't go crazy on that. Then if you're like, okay, there's no way to go, then you go to your false. So your false kind of becomes sort of your fallback branch. That's like your last case scenario, worst case scenario branch, okay? But before that, you can also have, other things evaluated true. Red? I think we haven't used red. Yeah, red's good. Okay? And you still have your statement here. Now the important thing here, this is where it's going to get a little interesting with the drawing, is the true only runs if neither one of the two run. And if the green one evaluates, it's going to skip checking the other one. So it'll look more like this in this scenario, okay? I am running out of colors here. It's a major problem, I suppose. Let's take a different shade of green, okay? Actually, I think I can use this one. Okay. So let's see again how this path goes. Okay, so we're going to ask it a question first. We're going to be like, if, let's say that we're comparing whether a number is greater than, equal to, or less than another number. Okay, so we check first, like if A is greater than B, go to true. Then you check on the else if. Well, if A is equal to B, then go to here. Otherwise, if it's false, then you go here, which must mean that it is probably less than B, right? So that could be a good example of you using an else if clause. So you start out by saying, if A is greater than B, go here. If they're equal, go here. Otherwise, they must be less than, go this way. Okay? So you have your 3 different paths, all leading to the stuff afterwards. And of course, all having stuff above it. How do we change this to look like that? We just make more space. And then put the else at the bottom. You want to keep that at the bottom. So let me just grab that properly. So we'll still keep that down here. And what we're going to add in here is we're going to add elif, which is again else if. It's abbreviation. Again, Python all about shorthand. In C++ you have to write the word else if. But in Python they just shorthanded that. Kind of like in Bash. And then here you would write your second condition that you check, which can be completely different than the first one. In fact, it should not be the first one. It should be a completely different condition that you want. Whatever it is you want, but something else. And then put your colons again. Okay? And then if that evaluates is true, that's when you're going to run that code. I hope the color coding stuff is useful because it's taking a lot of time, but trying to make this a little bit visually stimulating. So now I got to remember which colors I use for what. This is red. And then the other one is the sort of purple here, okay? Sorry I can't get this all in the screen without making it really tiny though. But maybe I can if I zoom, if I shrink it, but let me first finish it. Okay? So that would basically be what it's like. Again, this will run here if the else if statement, which in here I'm actually going to call else if instead of elif. That's usually what I call it. What's very important to remember is that this condition will never be checked if you go into the green. Again, look at the paths here. If you hit the green, you go all the way to the purple. You never check the second one. The only time you check the second one is if the first one evaluates to false. And then, again, if you go into that one, you never go to gray. The only time you go to gray is the fallback, when both the first and the second condition are evaluated to false. Okay? So that is pretty much what it's going to look like. I'll do very quickly one example of what this is going to look like in code, but you know, we'll do more examples next class live. Let's try to shrink this a little bit so that we can throw in there this. Okay, there you go. It's a little bit bigger. Best I could do. All right. So you can take a screenshot if you want for reference. Okay. So let's just do that in here. So let's just do the one that gives you the 3 values, okay? So bar 1 is going to say int input, enter a number, we're just going to call this A actually, and then B is going to be enter another number. And so we're going to check whether one number is greater than, equal to, or less than, okay? So we are going to say if A is greater than B, then we're going to print out first number is greater than second number. Else if A is equal to B, we're going to print out both numbers are equal. And then the else is going to be print second number is greater than first number. Okay? And then at the end we're going to say thank you for playing. You don't have to have anything afterward, by the way. You can end on an else statement. But, you know, I'm just putting it so that the example is complete as it looks here. Okay? So let's enter a number. Let's start out by putting a 5 in there. Let's enter a number. Let's put in a 4. It says first number is greater than second because it goes there. Okay? If we look at the debugging of the code, do I have the debugger set up? I think I do. So let me put a breakpoint. So I put in 5. It says hit the breakpoint. Enter another number. Let's put a 4. Oh, there we go, 4. It goes into the if statement. If A is greater than B, it runs into there. It hits that, and then it goes immediately to the bottom of it. You see that? So it skips all of this because it validated it true. Put the break in there, okay? Let's try to run it with other numbers. Let's see where things are equal. So let's put in a 5 and another 5, okay? So it checks if A is greater than B. And it's like, nope, it's not. So now it checks if they're equal. It says yes, so it goes in there. It says both numbers are equal. And then it goes to the bottom and says, thank you for playing. You see that? Notice how I have everything nicely tabbed. What I'm saying is, don't do this. It'll run. This will run, but like it just looks bad and confusing. So you want to make it nice and flush, but you want to make it tabbed. Again, if you do this, then you'll get an error. It's going to yell at me. Expected and indented block. See that? So be careful about that, but also be good about it. All right, final case. Let's run it where the second number is bigger. So let's do them 5 for the first one and 10 for the second one. It checks if A and B are, you know, 5 is greater than 10, which is not. It checks if they're equal, they're not, so it automatically goes into the else clause, prints out that the second number is greater than, says thank you for playing, and it is done. So there we go. Just as I hit done there, we hit our time limit for the day. But hopefully this has given you a good introduction into what the if statement is in Python and in general. The if statement, again, is very important. It's syntactically very simple to understand. Like, you can see how there's no rocket science to writing an if statement in Python. The rocket science comes in when you're trying to actually make the logic for the if statement to work correctly, and that's what will take some time to get it working. You know, to be able to create those and ors and complicated if statements and making the logic clean. That's what will take time. But of course, you know, like anything, it's just practice and perseverance and a little bit of critical thinking, planning ahead before you write these things. So with that said, you have seen the if statement, you've seen the if-else statement, and you've seen the if-elif-else statement. You could have, by the way, an if-else-if without an else clause. That's perfectly fine too. You have if-else, you can have if-else-if, and that's it. What you cannot have is just like an else or like an else-if-else. You always need to start things with an if. And then everything else after that, you're good to go. So next time, we're going to be looking at more examples where we have like a if, else if, like multiple branches, more than just like 3. And then also we're going to be looking at nested stuff. So our little graphs here are going to become pretty hardcore. I mean, already you saw that this looks pretty fancy right there, right? Control flow. These are, by the way, I call control flows. Yeah. The idea is that this is not to make your life harder up there. That's to make your life easier. By understanding how to do these things, you make your code do your bidding so that you can be relaxed, you know, just watching the code run and enjoying the sun. Okay? So until next time, I hope that you have a good weekend, and thanks for watching, everybody. Take care.